live. So
skip 1 or 2 more minutes. All right, I think we can get started then. Awesome. Well, again, welcome everyone, everyone that's viewing us remotely. Thank you for taking time to join us on a fine Sunday afternoon, or for our members in the Asia Pacific region on Monday morning. Highly appreciated. This is our session for the Silicon Valley Leadership Community, SVLC. Our topic today will be how to build and develop a impactful and effective artificial intelligence and machine learning organization. We have two great guests with us on the panel today. I'd like to first jump into a quick intro to SVLC for those viewers who are new to our online format. So I'll do a quick screen share, and then we'll get started off. All right. So to those not familiar with the Silicon Valley Leadership Community before, we were founded last year by 4 top tech community company executives. We're actually one of the fastest growing leadership communities in the region, and our members come from across different unicorns, Fortune 500 companies, startups, and also from venture capital and different academic backgrounds, to help develop and foster a spirit of leadership, mentorship, and build a community of helping one another to develop our careers and share insights across industry and best practices. So some of our previous speakers at our events earlier this year have come from companies like Box with Paul Chapman, Erica Lockheimer at LinkedIn, and Li Fan from Lime. A lot of illustrious speakers here. Some of the previous topics we've covered this year have also included crisis or opportunity, transformation of organizations due to the COVID situation, the future of education, future of workforce, cloud transformation, cloud transformation's impact on enterprises, and the impact on the remote workforce situation. We've also had industry-specific events regarding either the travel and food industry, online entertainment and streaming, as well as education. And we're looking forward to putting up more and more events online, given the current remote situation. So I'd like to also thank 2 of our marketing sponsors and partners for today's event. The first is Flag Dream. So Flag Dream is a partner that is focused on talent development and training and technical skills, relying on their strong resources, network, and mentor teams throughout Silicon Valley and Wall Street. Flag Dream provides talent with career development, consulting, vocational skills training services. And each year they send thousands of trainees to Silicon Valley top companies across various industries around the world as well, not just purely Silicon Valley. That is our core. Our other co-sponsor for today's event is Intellipro Group. So Intellipro Group, it was founded in 2009. It is also headquartered in Silicon Valley and is one of the leading strategic management consulting and human resources solution providers in North America. With AI, big data, and SaaS technology, Intellipro has established a powerful database of high-end talent to become a global partner of many first-class technology companies. Intellipro also offers services such as executive search, IT consulting and staffing, RPO, corporate training, and overseas campus recruiting. But without further ado, I'd like to introduce our two distinguished panelists today. The first is, I'm going to check our deck is on the right slide. Okay, great. So our first guest today is Dr. Chucheng Xie. He is the Chief Data Officer at Etsy. Dr. Chucheng Xie leads the global data organization at Etsy, and their teams are located in Brooklyn, San Francisco, Toronto, Mexico City, and a few other locations as well. He manages the Data Technology Group, the Applied Science Group, Machine Learning Infrastructure Group, and the Experiment Platform Group. He drives and supervises data strategy, AI innovation, machine learning, and data infrastructure for Etsy. Previous to joining Etsy, Chucheng led the AI machine learning teams at Rakuten, Intuit, and was the head of Alexa voice recognition at Amazon. He received a PhD in computer science from UCLA and has published papers on AI and ML in journals like WWW, Seeger, and KDD. Our second distinguished panelist today is Pradeep Chavangula. He is the Vice President for Artificial Intelligence and Machine Learning at Workday. Pradeep heads all machine learning and artificial intelligence platforms and solutions for Workday, and he has recently led AI innovations and platform initiatives with Symphony AI to invest and build B2B software companies in healthcare, industrial IoT, retail, CPG, fintech, talent, legal AI, autonomous data centers, and other enterprise solutions and other verticals. As VP previously at Adobe, Pradeep led the engineering for Adobe Marketing Cloud Platform, AI and machine learning efforts for personalization, data management, mobile and content marketing. And prior to Adobe, he was CTO and founder at Tumri, a dynamic and creative optimization and ad serving platform. It was acquired by Collective Media and then by Adobe. And then previously, he held senior architect engineering leadership roles in search and personalization software companies, Inktomi and Verity. He received his master's in algebraic number theory at Oklahoma State University and a master's in mathematics and engineering from the Birla Institute of Technology. Pradeep is passionate about envisioning, leading, building, and monetizing scalable SaaS products, relevant adaptive software platforms to deliver personalized digital user experiences for consumers and business users. Pradeep and Chucheng, thank you for joining us today.
Thank you, Ross.
Yeah, thank you, Ross. Happy to be here.
Fantastic. I thought we would jump right in. I figured the topics we were going to cover, we'd start from the individual and kind of move outward to a more broader view of to an organizational and industry-wide scope for our questions. So I thought first we'd talk about everyone's personal career development and some lessons we can give to our up and coming and ambitious leaders in the SVLC. So first, I would love to see if you'd be willing to share your thoughts on the pursuit of academic versus a business career path for those focusing on the AI and machine learning skill sets. And I know both of you have pursued academia. Pradeep, I know you'd pursued a PhD, and Chucheng, you actually were a teacher at UCLA before switching into the private sector. So I'd love to hear your thoughts.
Go ahead, Chucheng.
Sure. So by the way, thank you everyone for coming today. Every time people ask me about academic versus industrial, I would say both are very rewarding. I actually teach in university even before I get my PhD. And I find that I have to get a PhD to get a professor job. So I have no choice. That's why I decided to pursue a PhD in UCLA. And I'm very lucky to work with wonderful advisor and a lot of good researcher. And I will be very humble and honest saying that when I work with them, I know there's no way I can be this guy. They are super smart and they are all high achiever. But that doesn't mean I cannot get my degree. I still get my degree. I write a few papers. But honestly, when I'm looking back, I said that, wow, there are tons of people who are much better than me. And I ask myself that I have a choice I need to make, right? So at that moment, I actually thinking about, is there some other place that I can still using my research skill, my science background, and I can still make an impact? Like a professor is not the only way out. And On a side note that I was having a family on my last year. I have my kids in my last year of PhD, and that is the moment I start thinking money is to some extent a little important. So I need to think about my family, and I think of my personal career, and I find that there are actually a lot of opportunity outside academic, and that's why I kind of switch track. And a lot of my friends still staying academic, and they are all very happy. So both are great like choice, and I think these days both you can get a very fulfilled career. That's what I thought, and especially if you are doing AI and machine learning, and you can see that a lot of usage in the industry today.
Fantastic. Yeah, and Pradeep, what inspired you to make the switch from the doctoral route into the private sector?
Yeah, so yeah, I'll recount my stories. Some of those are clearly an overlap with what Chu Cheng had been talking about in terms of financial needs, and where can you make more money is always top of mind. But that was not my initial motivation. I mean, when I came to the US to do a PhD in mathematics, in particular in algebraic number theory, it is as far away from any kind of an application as one can think of. This is purely, it's like doing research in a very esoteric area of number theory, which is just aesthetically very beautiful, right? And so it turns out that Oklahoma State, where I was doing my PhD, is actually one of the best in the world for number theory research. So I had a really terrific time. And so, my PhD progression came all the way through to sort of all but dissertation is what people call it. So I had probably about a year left before I could sort of write it and defend it and call it done. So my undergraduate degree was a double major in engineering, in particular computer engineering and mathematics, and I chose to go the academic route and the research route. So after my fourth year, I got a summer job to work at a small graphics company in Southern California, like south of LA in Orange County, right by the beach, Laguna Beach. And it was a nice, terrific company that was building sort of high performance graphics kernel systems, right? And so, I enjoyed the job quite a bit. And so at the end of the summer period, they said, it's like, hey, we like you a lot. We'd like to give you a full-time job. So I told my advisor, yeah, I'm going to, take probably a year off, come back and finish. And I never did. So, because I sort of, liked the aspect of doing sort of, software. In particular, my interest and skill sets, frankly, are much more aligned toward mathematics-oriented software, right? And, back in the mid-90s, AI and machine learning, this is almost like pre-internet even, right? Netscape had just come out, but the prospect of being in the dynamic software industry sincerely appealed to me. So that's sort of the reason why I never went back. And frankly, I don't actually have much regrets about that. Right? It is, I have luckily pursued down a path which always was at the intersection of high performance platform and systems oriented engineering combined with algorithmic mathematics, data science, machine learning, AI, and predictive intelligence. And I got lucky as I started out my career in Silicon Valley with Sun Microsystems building sort of Java, JDK, and the Java virtual machine initially, and then switched to, well, also the startup bug bit me. So started a company, and then quickly thereafter moved to a web search company. Before there was a Google, there was a big web search company called Inktomi, which was eventually acquired by Yahoo. Right? So the Yahoo, Bing, overall software stuff is where some of my probably dirty hands are still in terms of what we chose to do. So just in terms of sort of like overall advice about academia versus business, I agree with Chu Cheng in terms of both are extraordinarily rewarding, right? It is when you're in academia, you're working in sort of a much more of an individual oriented approach, right? And presumably with a small, highly talented, highly specialized group of individuals that are at the bleeding edge of specific technology or math or science or or something else of that nature. It has an inherently different feel, different way of life evolves if you are a part of the academic ecosystem. Whereas in the industry, it is a little bit sort of, much more all-encompassing, right? In the sense that you have the ability and the freedom to move around a fair bit, right? It is, if this doesn't work out, you can go do something else or pursue your passions and interests in a manner that academia really doesn't quite offer that level of flexibility, right? And of course, as Shu-Chin pointed out, the money is good. So, and the money is important,
Yeah.
right? And the other aspect is also that I think impact has always been a fairly big aspect of my career, right? The things that we build, things that we spend a bunch of time of our lives and careers on should touch people, right? If they have the ability to impact a large group of users or community, as in the case of Etsy, or in the case of Workday, or as in the case of Adobe, and many other companies that we have been lucky to work at, these things do have significant impacts. I wouldn't call it to the extent of sort of transforming lives, but for sure, the satisfaction that one gets from these things being integrated in with specific products that people use and like is a deeply satisfying experience.
Absolutely. I'm sure I've been recommended a decent amount of products on the Etsy platform, and for Workday, I know there are so many people that because it looks at so many large scale organizations for their personnel management. It impacts everyone, from a compensation perspective, career development, and even monitoring for retention purposes to improve the effectiveness of everyone's organization in the company.
The sum total of employees and workers that are served by the Workday platform is about 45 million in the US alone. So it's a fairly large impact that we can have on people's work lives. Right? In some cases they're super interesting. In other cases they're a bit mundane. So
it's a great data set for sure. I guess another question I would be interested to ask would be, during your transitions as leaders, you've gone through smaller companies, you've gone through startups, right? You've also gone through a variety of larger organizations, right, with tens of thousands of team members.
Mm-hmm.
As you developed and began to manage very highly scientific and very technical teams, what advice would you give to leaders who are new to managing teams or new to managing managers, and especially of other R&D related organizations, other AI machine learning impacted organizations?
Okay. I'll start, if you don't mind, Shu-Chin.
Sure.
Yeah, sure.
Yeah, go ahead, Worthy.
There are a few key principles that I have followed, and as you rightly pointed out, Ross, I switched from being an individual contributor and an architect to being a leader, and my first sort of like leader position was actually a director, which is a little strange. Right? Most people grow within the ranks of engineering management, but this is a unique set of circumstances during the internet bubble, right? So, I did feel like a fish out of water, right? Switching from being much more of a person thinking deeply about architecture, technology, software development, and algorithmic stuff over into managing people. I think, the first principle that comes to mind is authenticity, right? Which is that if you're going to, and this is no different for machine learning or AI teams, this is a generic leadership trait, is that, you want to be in a position to be able to garner sufficient level of respect. And for having been there, done that in some capacity, so that you're seen as a mentor in addition to being a boss by your individual teams. And it's a value system that I go by. Second is, it is one's own ego needs to be kept in check when one is managing teams, right? It is, you're not being counted upon always to be the solver of problems. It is really always about consensus building among potentially a diverse set of ideas or thoughts that come together. And what you're being counted upon as a leader is to course correct based on your prior experience, right? You know, when it's veering down a particular direction that you have seen before, that isn't likely to work, that's the core value add that you bring to the table, right? But and it's a delicate dance, right? If you are the most experienced person in the room, and if you have been technically adept at solving specific problems, your instinct is to jump in and do it yourself, as opposed to ensuring that there's the feeling as well as there's the actual process of problem solving that comes organically from the team involved, right? And three is, I think, as a tech leader, it is, you shouldn't veer too far away from the what of like what you're doing and the why of what you're doing. Typically, that is the domain of product managers, right? Meaning, what should we be building and why should we be building it, and who are the users and constituents that are going to be leveraging this particular feature, tool, or product, is something that you want to internalize as much as possible, right? And internalizing that gives you clarity, a certain sense of mission for why you're doing what you're doing, right? And to the extent that the engineering teams are largely responsible for the how, right? And you know, the how is bound to a set of metrics in terms of performance or efficacy or, you know, measurability or observability or, you know, deployability and so on. It's pretty important to deal with that. And the last principle that I'd say is like it's empathy, right? And empathy for not just your users. Clearly that is required, and you know, one relies on the product managers to get that. But it's also about, if you are an engineer, ensuring that the QA team, you're empathetic to the QA needs, or to the technology operations teams in terms of what deployability consists of, right? This is the other part that's quite important, meaning that, you know, if you end up in an organization where people are doing stuff and throwing it across the wall to say it's like, hey, it's your problem now, that spells disaster in most conditions, in most organizations. So I feel that, you know, these four principles are pretty important. It's like authenticity in terms of being able to garner trust. 2 is reduction of your ego. 3 is much more of a cross-functional involvement. And 4 is empathy for both people inside and outside the organization. Cool. On to you.
Yeah, I mean, I second Pradeep. I think he shared a lot of insight that resonated with me a lot. And I can also share some thoughts that in my career, I actually stopped my own company maybe 15, 16 years ago, and I failed. You know, I went broke, like run out of money, need to let go everyone. Trust me, it's no fun at all. And I joined a startup and eventually getting acquired. We call it the exit, but it's not a going IPO, so you don't get a reach. It's just you know, time for move on to another adventure. I happen to also join one of the biggest company in the world, like Amazon, with more than 750,000 of employees at the time I joined. You know, so I see different spectrum of the different sides of the company where I work. And one thing I learned, which I really like, is there's a book called The Startup of You by Reid Hoffman. And he always said that life is more like a startup. But to me, life is more like an A/B test. You need to A/B test yourself. You need to know what you like. Some people, they are fortunate. They go to PhD program. They say, here's my thing. I want to become an academic professor. And I envy those people. For me, it's taken me many, many years to find the things I like. And I think eventually I come to a place that I really enjoy my job and I'm happy. I wake up with energy every day. And if you see that it's actually a coincidence, because my PhD thesis is actually trying to find the social behavior on this kind of recommendation system. And this exactly aligns with like Etsy's purpose called keep e-commerce human. If you connect them together, you see how they define things. Basically, their mission is my PhD thesis. And there's no way I can predict that like 10 years ago when I started my PhD. I just said that the life eventually will find a way if you keep trying. And the advice I give to leader is that I think everyone, no matter it's about yourself, and no matter if you're running a team, you need to learn one thing is understand the constraint and the success. And many people doesn't know what constraint they have and what kind of success they are looking for. And if you don't know what success you are pursuing, if you don't realize the constraint you have, then you won't be happy. So I think the happy is by understanding the constraint and the success. This is something I actually learned from Josh Seelman, our CEO, when I come here and meet him, and he shared this advice. And I somehow figure, finally, I know how to frame like the things I'm trying to convey. So I also want to share that advice I get with all of you. I think those are interesting perspective that I kind of put them as part of my operating principle, like arguing in my head.
Awesome. Well, then definitely makes sense. You need the goal, but you also need to know the capacity to deliver, right? and
yes, exactly.
Absolutely. Let's see. I think for time, we might go on to talking about more of the team building, organization building piece of your experience. So there are a lot of executives, and I know a lot of the leaders who might be watching our event today aren't necessarily from a machine learning background or a data science background. So they don't necessarily have the experience of building an AI team or an AI department. And it's a relatively recent development for most companies to start incorporating that into their business models and into their organization structures. How would you go about suggesting to those executives how they potentially should consider building the initial kernel of an AI team, and what are kind of the life stages that you envision as being key milestones? I think Chuchang, if you'd like to speak to that first.
Sure. It's actually, that is actually, by the way, very good questions. And there's a good question, but they're very hard to find a good answer to that. But I can share some opinion. Doesn't mean it's always true. But what I want to first remind, if you try to build an AI machine learning team, people with this skill are super, super expensive in the Valley or even in America because the demand and supply. Every company is going to this kind of transition. They understand the value of the data, the value of machine learning. They all want that, right? So before you do that, you need to ask yourself, what is the success you want? That's why I say you need to understand the success in your constraint. And there's a friend who tried to start a company. He asked me a question. He said, you want to do AI machine learning? I said, okay. He said, you want to hire one person and to do all this job? I said, yeah. And then when I learn more, I know what they actually need is not really a scientist. It's just someone who is actually an engineer and how to do some data engineering, right? So my suggestion is that you don't need to hire, especially if you start your department, no matter you are startup or you're a big company, you don't really need a PhD like a scientist to start with. There are these days machine learning has been quite a popular training. Everyone kind of can get to some degree, and there are a lot of practitioners you can find in Kaggle, like a contest or a lot of place. So if you want to start, maybe what you try to do is find a generalist, someone kind of have been doing things for a few years, and then that help you to understand what you may use AI machine learning to help you. And I always say that try to find some way, this kind of philosophy is the same. Like recently, 4 months ago, I actually launched a program called Etsy Summer of Vision. And I actually hire 21 students, and I tell them that to do whatever you want in computer vision, AI, machine learning technology. I mean, I pay, and your idea, right? Do the cool stuff and show me like what you can do in 3 months. And the outcome is amazing. They have so many cool ideas, and they're using so many technologies that I cannot even imagine it before they try. And do they get a PhD? Yeah, 1 or 2, but most of them even don't finish their master. They are students looking for summer interns, and we do that because I know COVID hit hard on many industry. A lot of offer getting canceled, so we target for whoever lost their offer during their because of COVID, and we do this kind of thing to both help people. But the outcome is actually much better than I thought. Like we are wow, like every time we hear their presentation. And that's changed my mind is that I think that today you don't need to be hiring PhD to start with some cool project. I think there are a lot of people who can bring this to you. So trying to hire someone with energy, with passion to make an impact, and then give them some freedom, and I think they can amaze you. That's kind of my my thoughts about building a team, especially if you don't have a team yet.
Awesome. I mean, because I've heard previously that companies would say, "Oh, we need to get an expert data science, like really senior like tech expert," and then maybe they would have there's sometimes a segmentation between the data science team or the tech expert team, and then a separate class of engineers or software engineers, and it's not necessarily as integrated. But it's interesting to hear kind of a unique approach that you've taken at Etsy. That's fantastic.
Yeah, I mean, to some extent, I think there are different ways of operating scientists and engineering. Of course, in a very big company, they probably create a science team and they have an engineering team. They find a manager and figure out a way for having them to work together. They can create a certain kind of workflow. But if you just start it, then I think you don't need all you need is just a few people and to try. And because often when you start something, you don't even know what success look like to you. And I think one thing I learned is for any AI machine learning project, you need to budget in certain degree of exploration. You cannot start with say, I want this, right? I want auto driving car, build that for me. Sometimes you don't know whether the technology is ready or not. All you need to do is that first, like it's not what you want and people can build for you. There's a final difference. In engineering, usually I say, you have PM, you're working backwards, you have a requirement document, and someone can build this for you. And I think I see a lot of companies, they're trying to copy this process. Like, okay, I have a PM. I want you to build me a car which can drive itself and like a taxi. I mean, I'm not saying this is impossible, but if you see the technology today, I doubt that it will come to us like in next 6 months or 12 months. It's just technology is not there yet, right? So there's a process that kind of what technology can do and what people want. And I think the trick here is that how you kind of create a mechanism or process that both of them come close to each other. I think the traditional way of doing product like design first and working backwards in machine learning can be very, very tricky if you don't play it well.
Interesting. Pradeep?
Yeah, I'll just weigh in. I'll second everything that Chu Cheng said, but my experience has been of the following two varieties. There are companies that I would consider to be sort of first party companies, meaning that a Netflix or Etsy or Amazon or Walmart among the larger ones, or people that essentially have some sort of, or a bank, right? Or any one of these companies where the technology is not the thing that you're selling, right? The thing that is being used is actually a service, right? And that's one class of companies where a different organizational structure or different ways of thinking about data-driven technology applications need to be considered, compared to the technology platform organizations, such as Workday or Google or Adobe or Oracle or SAP or any one of these other enterprise software technologies companies, where the intent is actually to embed machine learning and AI at the core of their software solutions that are then being marketed and sold and used across a wide variety of industry verticals. So both of these are sort of different in different ways. So for the former, I would say it's much more of domain expertise and knowing or understanding from your peers or from folks that have gone before you what the art of the possible is before you figure out whether you actually need a data science team at all or not. Right? Like, it is clear that you need statisticians for risk modeling, right? Or for insurance underwriting, or credit card assignment, or recommendation systems in a media or entertainment world or in the commerce world like Chu Cheng does and so on. Right? And so it's a slightly different orientation where since you are the first party, you're normally in possession of a lot of data. And with that data, experimentation is absolutely, absolutely mission critical to figure out what is likely to yield the right kind of metric and result, which is also another thing that Chu Cheng pointed out. It's like, put the box around what success actually looks like. Right? If you are building some personalization solution and you want to see, for instance, what kind of a lift actually warrants a pretty big team to support it. Right? I mean, and in order to do that, you have to do an A/B test, right? Control versus test, right? And to figure out whether your results are actually yielding the right kind of analysis and so on. The technology organizations that are attempting to build AI are slightly different in terms of there you actually want much more of a blend between engineering and data scientists completely commingled with each other, right? It is having silos that actually doesn't help, right? Meaning that you want as much of systems engineering and scalability and performance needs to be front and center to whatever it is that you are doing. And generalizability is a very huge problem, right? Meaning that what works for one data set and one customer doesn't work for another customer, even within sort of potentially the same vertical, right? And when you're crossing vertical boundaries, like I'll give you examples from Workday, right? It is you're attempting to find an effective match between a job and a candidate. It's a very different sort of algorithm is likely to work based on the data patterns between the healthcare system versus frontline workers at Target, right? And so it is. The problem set is actually much different and more difficult in the enterprise software organizations, and I'm not saying it's easy for more of the B2C or B2B end customer facing services, but just in terms of like the organizationally, I agree that energy, education, and commingling of a group of people that are educating each other is super important, as opposed to some highfalutin sort of like research experience. Really, I mean, it is. I personally am of the opinion, it's maybe a controversial opinion, I don't think you need bleeding edge technology solutions to solve most problems. You kind of need common sense. You need to understand how the existing algorithmic approaches actually are feasible and technically how do they work, both from a systems perspective as well as from the actual math involved perspective. And knowing how to merge this particular technical approach to a problem that you want to solve is the orientation that you're looking for. I don't have a magic answer for like how you go select people, right? It is, if you don't have some basic levels of mathematical maturity, it tends to be harder. If you do not have some good enough understanding of how software is developed and deployed and delivered and tested and so on in terms of the software development lifecycle, you're not going to have a well-rounded team, right? So as such, teams should consist of all of these complementary skill sets that would drive success. That's been my experience.
So I mean, it really depends, one, on, as you mentioned, there are two different things. One is, are you really going off of as a company, the industry vertical, the wide breadth of customer data essentially that you have, or industry expertise,
right,
executing in that space, versus are you going to be relying on building a lot more core
software, yeah, right. Mm-hmm.
Yeah. And applying that across multiple industries, because even if you're applying, it's interesting that you mentioned the situation of saying like hiring folks for Target versus hiring someone for a bank, right? Even within the same company, there's so many different use cases and so many different skill sets that are being utilized.
Right.
There's a lot of adaptability there. Yeah. Absolutely.
Yes, and I also want to add one thing which I think is very. I think I think I totally agree with Pradeep. And always I come to our CEO and I tell him that I always ask him this question: you cannot be the best on everything. So what you want to make Edison the best, like in AI machine learning. And some of them you can just, just accept that good enough is enough. I think that is basically a concept also as a leader you should be doing to yourself. You cannot be the best of everything. You can only best in one or two AI machine learning stuff, even in the big company.
I remember you think last time we spoke, you had discussed even within personal career development, the goal wasn't to be the number, like the top 1% of one particular specialization. It was to combine 2 or 3 different areas where you're the top 10% or you're the top 5%, right? And then to combine those together to have a unique intersection, essentially, of expertise that's going to be very, very valuable.
Yeah.
What would be your thoughts on creating in-house like AI academies in different organizations in order to kind of evangelize a little bit more?
I think it's huge. I'm a very, very big proponent of it, partly because of 2 factors. One is the technology itself is fairly new, right? And it is changing at breakneck pace, right? I mean, there is, it used to be the case that there's sort of like once every 6 months, there would be a very seminal new paper that gets published in a particular area. Within machine learning and AI now, I would say seminal papers are getting published at least once every month, number one. Number 2 is that the underlying technology platforms are evolving so rapidly, all the way from silicon, right, from GPUs or this neurocomputing and other sorts of things that are on-device stuff that's going on, all the way up through cloud and storage and everything else that's going on. It's an extraordinarily complex ecosystem, right? And what end users don't see any of the complexity underneath, right? So in order to do that, you want a team that is sufficiently intellectually curious, not to be sort of, going off and figuring out how did the Google Go thing work, right? Okay, that actually may not be a relevant problem for you to go research, right? It is. So to that extent, basically what I have started at Workday is something called an applied research program, which is it's a pure sort of like, voluntary basis. So it is people sign up and we invite external speakers, much like here, to come and speak to them about specific topics of interest that they are experts at, and they're wide ranging. They sometimes don't even have anything to do that is relevant to us. That's sort of like one way in which external infusion of knowledge interchange happens into a given company. Secondly, there's only so much time besides your day job to be able to go read papers and work out the math and figure out whether something is actually relevant to you or not. So the way to where we've done it is to say a small group of people volunteer to actually study deeply a specific paper or technology and all the aspects of it, and then contemplate on what its applicability is going to be for our use cases, for our products, and for our mindset. And then they teach in some sense, right? So they go off and explain what the paper is and what their research has yielded and how it's relevant to us and so on. So, you can take it to the next level as well. In fact, we, in other companies, both at Adobe and at Symphony AI, we were an incubator by definition. So which meant that we were constantly evaluating new applied AI solutions in different verticals. It can be something very deep like, geophysical data exploration for oil and gas industry. And most regular software engineers or data scientists simply don't have enough of a knowledge of that particular domain. So we would invite external people to come and educate us about that specific industry, right? Especially as things start to get much, much more specialized. And in that process, what ends up happening is that you are actually building up the muscle of seeing what does an applied AI, applied machine learning, applied data science, and systems technology look like when applied to different industries. It sort of, builds up the muscle of, I would say, entrepreneurial thinking. And So, both from a research perspective, as well as from encouraging internal entrepreneurialism inside of your company, it's a win-win for morale. It's a win-win for everything that people do. It is, and most companies cannot afford a Google-like big research org, right? It is, and research shouldn't be just about this ivory tower research orientation. It really is. It should be much more grounded in terms of what does it yield for our own product evolution. That's why I think the whole academy or an applied research oriented initiatives are really good, not particularly very expensive initiatives to start.
Excellent. And so the academies, oftentimes it would seem that they would be sitting in, I guess there's the hub, and then there are the spokes potentially within an AI organization, whether it's a centralized team, and that's kind of a repository of deep insights, common knowledge, like good best practices. But then there are the spokes where potentially AI team members are embedded, maybe with a product manager, into different business units or assigned to different client cases, for example. And there's a balance there to be.
That's how we operate today. We operate in this hub spoke model with the notion of a centralized platform and a core sort of like ML intelligent core organization with groups that are embedded into each of our application business units that are cohorting very closely with the application business units to evaluate what should we build and is this feasible, when should we be building it, what the potential cost of it is, and so on. So it is, over time, the out of this center of excellence kind of initiative, it propagates to most organizations in the company, right? That's the thesis.
Excellent cross-pollination.
Yes.
And Chuk-Chang, I'd love to hear how, in your experience, have you started off with the core hub, and how have you evolved that hub and spoke organization in your experience?
One thing I find extremely interesting is that software, we have Agile, we have a lot of things which has been evolved in the last maybe 30, 40 years. But AI machine learning, especially AI machine learning for industry usage, actually pretty young field that only maybe 10, 15 years. So if anyone interview for my team and tell me they have 20 years of managing AI machine learning, I say, you are saying a joke, right? 20 years ago, we don't have such a things. So there are so many things we know it's not going to work. For example, like I remember I was at eBay and eBay decided to shut down their research lab. We know that you create a research lab and trying to have researcher to build a cool stuff and then engineer to rebuild and put in production is not effective. I mean, even Microsoft research is more like really just for research. They may have some successful this kind of migration, but in general, most of the company don't do that anymore. Even in Google, they have Google research, but there are also a lot of embedded scientists working with product day to day. And at Edison, I think when I joined, they already operate in this kind of centralized and embedded like a way. They wanted the scientists to stay close with the product, and there are a lot of benefits of doing that. Of course, also a lot of challenging, because how can you keep the central strategy? In the meantime, you separate everyone out, and we are learning in the process. For example, one thing I learned in my career, you never embedded one person into a team, right? What if this person choose to take a 3 months vacation or have an urgency? You will have a big problem. So at least 2, right? So when you embedded, the minimum number is 2, and preferred number is 3. And we also eventually learned that the power or the importance of embedded a manager with an IC. Because if you're just sending a scientist there, they feel they are getting abandoned, right? Like say, I'm a foster child, no one take care of me. So I think the funny thing about this AI machine learning and working with engineer is because these things are so new in a way, everyone is trying. And my belief is that I don't need to find a solution. I just need to find something better than you. So I think if you're thinking that way, you just need to find something a little better than other company. And I'm pretty sure in the next 5-10 years, how machine learning and software work together, engineer working together will continue to evolve. just like we have this kind of agile practice, we have so many things that continuous delivery, right? All these concept in engineer getting involved in the last 10 years. I'm always joke with my team, like say, I really wish we have something like IntelliJ for machine learning and AI, but we don't, right? We need to, we have maybe using a Python, but this is still a software oriented, not a model oriented, like a way of doing things. And I think all these things are kind of my general learning. So I would say this is like we have some working group. The goal is to create a learning culture. I think one thing, especially scientists these days or machine learning, is it's always cheaper to train and also it's good for retention, because I think one thing I also learned from my failure is that people want to become stronger, better, and stay with the state of the art. So you either help them to grow or you watch them go. And I prefer to help them grow. So that's why I'm also like totally agree with Pradeep, is that I'm a fan of this like training and AI academy and inviting speaker and creating a learning culture, because if you don't do that, very soon you cannot retain any good talents in your team.
Absolutely, and with AI talent being just so in demand, the risk to the retention is even higher than on other teams.
Yeah, even retain engineer, right? Some engineer want to learn. Yeah,
right. And the senior folks like us who've have had successes and failures and so on, the younger teams absolutely do want to learn from our experiences, whether it be in startups or in large organizations, what worked and what didn't work and so on. And this is probably another trait that's important for leaders is, your patience and your interests in terms of communicating what you have gone through so that it results in their own career advancement, right? This is I'll do I have a book recommendation about this from Andy Grove, which is exactly what he suggests, and it has actually worked out quite well. We'll talk about that when we get to that section.
For sure. Awesome. And let's see, just for time, let's go on to kind of the topic of just general business impact. What would you say? They're in a lot of software companies. There's a concept of technical debt, right? All the legacy systems, legacy products that you've developed. Lots of people have changed in the organization. It's hard to go back and adjust that. How would you think about the concept of technical debt as it applies to an AI or machine learning team? Chu-Chung, if you want to go first.
Sure. I mean, actually, I'm dealing with a lot of those things right now. It's a public information that the agency decided to migrate from like a real physical data center to everything on the cloud like 2 years ago. So everything now is running on Google Cloud. So thinking about technical debt, I even have physical debt. I still have some machine there. I need to figure out how to get rid of that. And when we migrate from cloud, then we start to find even more technical debt. I see three kind of technical debt. Mm-hmm. The first kind of technical debt I call outdated, or like it's probably good in the past, but not anymore. The technical debt. In our example is that we start with building our data pipeline or machine learning pipeline using a scalding or Java cascading. It's a way of doing Hadoop processing. It used to be pretty cool, like maybe 10 years ago, but not anymore. Today, a lot of people are using Spark or other different technology. So we need to slowly evolve and start with some of them, and then we want to maybe get rid of scalding. And this is the technical debt. Some of data pipeline is working fine, and why you rewrite them, right? But this is a price you have to pay. Otherwise, you need to continue to support an old technology. I think this is the type 1, the technical debt. The type 2 I just mentioned is more like the physical debt. If you want to move from Google Cloud to Amazon Cloud, or moving from real data center to the cloud, there are always a lot of things. How can you do using native service instead of trying to treat everything just like a program? That's the second technical debt you need to solve. And the third thing I think is the most difficult to solve is I call it's working, and why you change that, the technical debt, especially in AI and machine learning. You see, like we're always using A/B tests to determine whether we launch something or not. So everything you launch on your website or in your app is actually A/B test, right? And when you decide to get rid of something, you don't know the cascading effect. You don't know what is the impact of the downstream if you, like say, remove this recommendation system, whether there will be some ripple effect that you cannot foresee. Long time ago, I remember I read a blog saying that everyone wants to rewrite their own code because reading code is hard when I was an engineer. And I think in machine learning, we have seen the problem. Everyone wants using the latest paper to solve the problem. And it's exactly the same problem that we haven't found a perfect solution because yes, from paper perspective, from A/B test, the new shining technology, like say deep learning, is better in tree-based model, like most search engine use in the past, like a GPT or these kind of things. But should you using deep learning technology, or you stick with whatever everyone knows, the tree-based model is working pretty well, which you can also understand why you make a certain decision. So there are a lot of these kind of migration on technology. The three perspective I mean, technical debt in me is more like I define it in a broader term is that your AI machine learning or your engineering need to evolve. And this evolve, eventually people call them technical debt. I think the question is that the technical debt will always be there. So you need to always carve out a certain percent of your time and resource to make sure you evolve. Otherwise, you are paying interest and you are paying higher and higher interest. And also you cannot focus on just get rid of technical data because whatever you think is the latest today, in 3 years, they are dead.
Right. Even sooner, maybe. Yeah, I completely agree. I think technical debt exists in every company, especially in successful companies. My rough measure is that you're in a constant state of refactoring, cleaning up, of modernizing your underlying, not just technology is utilized, but where it gets run, how development proceeds at all to begin with. I mean, it depends on the languages that are continuing to evolve, right? Embracing of the new tech is, you can call it a function of the technical debt that has been incurred, but things age, right? Basically code rots essentially, right? And all code rots, and you need to take cleanup measures from that perspective. Specifically as it relates to machine learning and AI, right? I mean, because these disciplines are relatively new, except in, say, search companies or sort of, deep in the weeds of financial services companies where there's a lot of statistical things have come about. There's probably not nearly as much of code rot as you would find in sort of, traditional software, right? And, just even without any kind of data science involved, just regular N-tier application software itself, as it relates to having to deal with massive amounts of data, having to deal with the underlying tech infrastructure itself dramatically changing. Let me just give you an example of the usage of SSDs, right, as high performance sort of memory can dramatically change the way in which your software performs or behaves, right? And if you're still operating under the assumption that you're dealing with a particular kind of storage and disk access and IO and stuff like that, it is you are operating on the wrong set of principles, right? So that's another sort of cleanup activity that needs to happen. On the ML front, I would say that it's not nearly a question of sort of tech debt, but coexistence, right? Meaning that in many places you have existing software, existing applications that are continuing to work. Your job is to infuse some level of intelligence into the way that software operates. And there are very viable design patterns, software and technology design patterns that exist that we can build in parallel. In fact, that's basically what a lot of companies that I know of actually do, where they build a parallel data stack, platform stack, AI, machine learning stack, and expose them via microservices or APIs and interfaces that can be called into. So it ends up obviously complicating the world, right, in terms of how these things get integrated. I mean, Amazon, I mean, you're probably familiar with this, Shu Chang. It's like each page is composed of sort of potentially hundreds of services, right, that are being called, right, with some level of a substrate that unifies all of it. So so this is this is obviously an in the weeds discussion, right, about how do you deal with it, how do you conquer it, and I don't think there is a panacea solution to it. It's like, oh, there is no company that doesn't have technical debt. Really, Google has tons of technical debt. Microsoft has massive amounts of technical debt. IBM has tremendous amounts of technical debt. So everybody has it. It's an engineering culture that needs to be propagated that essentially addresses it, and as opposed to shoving it under the rug, which is also a thing that I've seen. Right? It's like, yeah, well, it works. I don't need to change it. It's cool. I can survive for a few more years. It is the downstream impact, like Chu Chen pointed out, also is actually quite important. Right? It is, if you don't solve it now, what is it going to bite you with in 6 months, a year, 18 months down the road? So, and those are harder calls to make, but that's why, senior engineering leaders get paid the big bucks to make those kind of calls.
For sure. And to the extent, like on the previous question we had addressed on having the AI academies, on continuing to upskill your team members, the better retention you have folks in your team who have the vested interest, if they're going to be there long term, right, to make sure that they're there to fix that, right? It's not a problem. They're handing off to future generations of engineers, that they don't have to, like, they're there for a couple of years and they go, right? It's something that they'll have to live with their own future as they're developing within the organization. I think one more question I wanted to touch on before we switch into the Q&A segment of today's session was actually regarding your thoughts on the concept of being a VP of AI or a chief AI officer within an organization. Andrew Ng, the founder of Coursera and several other startups, he described in another article the AI leaders being similar to, I guess, about 100 years ago, when people were starting to use electricity in their factories and in all these different business applications. They had VPs of electricity. So now it's more like the VP of AI, the chief AI officer is serving a similar role as that type of an ambassador. So I'd love to hear Chu Chung and Preeti, both of your guys' insights on how you see the role of the head of AI or chief AI ambassador evolving over the next few years, and where it can have the best impact potentially across different organizations.
Yeah, I can start with this. When I see this VP of electricity, I have two feelings. One is that I may lose my job in 100 years because there's no more VP of electricity anymore. And the second thing is that I think
in 100 years.
Yeah, we are there. Yeah, so it's probably not an urgent issue need to solve. I always tell people that my job, although the shining part is about machine learning AI, I wrote a paper, and my team published a lot of papers, but that's not like, it's probably 1/3 of my job. I do much more than that. There are a lot of things. For example, compliance, data governance. How you make sure the company using data right, both within the law and how to use them in a way that is fair to our society. If you think about AI, it's actually learning a pattern. And unfortunately, that if you don't control them, they will learn what most people do. And that also means that if you are underrepresented minority, then your opinion will be ignored by AI. It's not on purpose. It's how machine learning was designed, right? You are considered as outlier. So imagine if Edison only show items that are from like a big seller. And if you are new to Edison, you want to sell something on Edison, and AI doesn't care about you because your revenue is so small. That is not right? So the second thing which I always do is that how can we ensure fairness, responsible AI? I think there's also a lot of things like it's also part of my job. I need to work with our team to figure that out. And the last thing which many people doesn't know is actually spend a lot of my time is on our developer experience. It's not just like there are a lot of things like creating a good platform, good infrastructure, So you need to productionize. It's not just writing a paper and you have a magical formula and everything will be on production. There are 80% of things you need to get it done, right? You need to figure out how to hook up all the data pipeline. And there are a lot of things to make sure stability, like a 999 or 59s, like a SLA, latency, and how much you spend. So actually I need to also do accounting, right? So I would say that, yes, I think a VP of electricity or VP of AI or Chief Data Officer is a very hot titles these days. But there's a reason for that, because at a certain point of your career, you go broad, and I think this is the moment that we go broad. We are not just doing scientists, AI, machine learning. We actually cover much more than that, and I think that's why you need to find someone to take care of these cross domain, and let's connect the things we talk about. I'm a believer that being 1% or 0.1% in any field is very difficult, and unless you are super talented, it's really, really almost impossible. But it's much easier to be expert, like say top 10% expert in data compliance, top 10% on engineering, plus top 10% on machine learning. Then you are already 0.1% in CDO, right? If you're thinking that way, it's much easier to be 10% on each field. And companies do need someone to be 10% on each field, because when they're making this decision, they need someone to make a decision that take care of everyone. And that's kind of making the right compromise is to some extent my job.
It gives you a much more 10,000 foot view, right? The more holistic.
Yeah, I would agree with that. I think, that is actually sort of the nature of the game, right? Meaning that if you are the head of AI or a chief data officer across the board, it is what's being asked of you, right? What's being asked of you is to be the leader to contemplate on, think about applying what is happening in the research and the scientific community to bring solutions to the problems that you have, right? Whether it be top line revenue increase or customer retention or bottom line profitability increases, and dealing with it in a responsible, governable way that is subjected to, in many cases, lots of regulations and governmental initiatives, right? And so this is indeed a very cross-functional need. So the problem is, if you take, let's say, a person that is very deep in the domain, say in cybersecurity, right? And they understand all ways in which crimes occur from a cyber perspective, right? And the application of some of these algorithmic techniques to solve that problem is the thing that is new, right? In terms of detecting patterns in vast streams of data using some of these, techniques and approaches in order to solve those specific problems that might potentially have been done by throwing people at the problem, right? I mean, I can tell you, for instance, that hundreds of millions of dollars are spent by banks dealing with anti-money laundering initiatives, right? About sort of, the security activity reports that are being filed, and the existing solutions that are largely governed by some SEC regulations result in about a 95% false positive rate. It basically means it doesn't work at all. 95% false positive. So, and you cannot include any other sort of much smarter solution without getting some regulatory approval. Even though techniques exist, you need to be sufficiently transparent about what this particular algorithm is doing. Right? To the point that Chu Cheng was making, it is, sometimes decision trees are actually the right way to go, as opposed to doing any kind of like a deep neural net, because the deep neural net, for the most part, is not truly explainable, not justifiable. It is sufficiently opaque. And to the regulator that is sitting on the other side, you just need to explain to them, what is this black box actually doing? If you can't explain it, then it cannot be deployed. They will simply stop it from doing that. Right? So again, depending on the domain, depending on how much governmental influence exists, how much regulatory influence exists, and these regulations are there for a reason. It's important to not worry about implicit bias in past data in making recruitment decisions or pay increase decisions or bonus decisions or all of the kind of decisions that impact people. I think we are at the cusp of having people that have knowledge of systems and engineering, math and algorithms, the domain expertise that is involved in a particular thing, and then tying it all together to understand, does this make sense for my company, for my business? That's the job. That's Chen's job. That is my job. That is the chief AI officer's job is exactly that. I assume when they meant chief of electricity or whatever, head of electricity, is like, given that electricity exists as a utility, now tell me what are all the places where I can use electricity, right? In some sense, that's exactly what we're talking about here, right? To the extent that electricity is isomorphic or equivalent to electricity, where all can these be used in order to improve my business operations? That's the job, right? And so it includes product, it includes strategy, it includes market, it includes regulations, it includes systems and engineering and algorithms. So, make sense?
Fantastic. Great. I think what we'd like to do now is kind of switch into some of the questions from our audience, from the attendees today.
That's great.
So let's see. I think the first question we have from our attendees was, how do you make sure there's diversity and inclusion is a big topic for hiring these days. How do you, I guess, ensure that you have a diverse organization when you're building your AI ML teams?
Yeah, this is an ongoing concern, right? It is, especially with the recent sort of socio-economic conditions and political conditions that exist in the country. This has become a very big deal. Our CEO is on record as saying we will have much more of a dedicated effort to having a 3% increase in our headcount as it relates to diversity and minorities and sort of representation from many different classes and groups. As it relates to encouraging diversity into our own ML teams, which are usually quite sought after, right? I mean, it is, depending on the size of the company involved, it's usually one of the higher paid jobs in companies. So there's a lot of, aspirationally, there's a lot of people that want to jump in. So it goes back to sort of like, how do you assess candidates? How do you determine what the key characteristics are that ought to exist in that person that have the potential to succeed, right? And it isn't about sort of like, do you know this particular Python library or have you read that paper? Mm-hmm. That's, to me, not important at all. To me, what is actually more important is, do you have the ability to learn? Do you have the grounding that is required in order to assimilate these new things and deal with the velocity of the technological changes, number one. Number two, by definition, ML and AI organizations are cross-functional. It is a high level of intellectual curiosity needs to exist about each individual being able to communicate well, each individual being able to understand what the on-the-ground problems are, and understanding what the gotchas are, and then translate them into a potential software or an algorithmic solution to a problem that's involved. And I think patience is warranted to the extent that diversity and inclusion being a pretty big thing, meaning that in some cases these individuals will not be able to hit the ground running, but that's okay, right? It is, as long as you've determined them to have the right sort of core set of skills that you care about. You want to determine, for instance, okay, a 3 month or a 6 month sort of boot camp program, can that result in them being a highly performant individual? I think the answer to that is yes, right? It is, in the end, we're teaching them a whole series of techniques, right? Techniques, tools, methodologies, and leadership being involved in terms of coaching them, training them is also a really, really important aspect in terms of trying to make that happen. Yeah, so I don't know of any sort of silver bullet here, but it is a thing that we're very cognizant of and are moving in that direction.
All right, great. And Chucheng, for the next question, I'd like to field this one to you. Is can you share a really challenging case study about how you've helped to lead a team to success?
This is almost like I do every day. Is that I think the first thing we need to define what is success, right? A case study. So I would tell maybe one of the example when I was in a startup, because I guess a lot of people here probably working in startup. When I was in a startup, I think the biggest problem I need to solve is recruit, because they're Facebook, Google, Amazon, even Etsy, right? Like they all get all the talents. And I was in a startup, and we try to retain the best people, and we try to find the best people. We also want to get diversity, and it's actually almost like a mission impossible. And we have very limited budget to make things worse. And at that moment, I actually learned a few techniques. The first thing I think I kind of tell constraint as a challenge, like a puzzle to solve. So that's why you wake up every day, because you keep your job because it's hard, right? So it's a tough job, and you start to think about it. So I kind of come up with a few things. For example, I figure out there are a lot of people who are giving a YouTube video on teaching machine learning online, or like they're winning Kaggle, and they don't have a PhD. I don't mind that they don't have a PhD. They already demonstrate the same skill set I need. So I hire based on skill, not a credential, so that I can target a few people that I think it's like people probably won't hire this undergraduate. They are just like a senior or sophomore at the school. But if I feel this person already demonstrated like the quality or the skill set I need, I try to make sure I don't have unconscious bias that I can only hire someone who has a PhD degree. And I think by being creative and treat the constraint as a challenge, I actually able to build a team in a startup fairly quickly in 12 months with like triple the team size. And there are, of course, a lot of tricks I do. For example, how to retain them. I remember, I don't know how I pull this off, but I managed to convince my boss, which is the CTO back then, to allow me to take the whole team to Las Vegas to do team events. Not the traditional team events you do in Silicon Valley, like say, let's have fun in Vegas, right? Let's go to buffet and let's have an unlimited drink covered by company. And turn out to be people who play together, stay together. So this kind of very creative like activity that you can usually pull through in a startup. But if you try to do the same thing in Etsy, Amazon, I will probably, even myself, would say, I need to check the company policy, because there are certain things company can do when they are small, because it's easier to manage. When they're big, they need to have a certain kind of rule to make sure it's fair. So when I in a startup, I think about what are the things I can do, but the big company cannot do, right? I can hire someone who doesn't have a degree, just high school degree, and maybe those people won't be screening by the recruiter because they don't even want to set up an interview. But I can act myself as a sourcer. I can just do everything myself. I can bring the team to Vegas. We can have a quality fun time, and then we fly back and we kind of family and friends. And so it's very hard to recruit someone's brother or sister, right? I don't think that is easy. So that's kind of my trick, is that I think one of the most challenging things is how to build AI machine learning for startup. And I think you need to look on your strengths, not just your constraint.
Fantastic. And I love how I guess as a startup you have to be very hands-on with everything, or you wear a lot of hats. But I love the very kind of hands-on and innovative way to establish rapport with them, because you're hiring for a team, not just an individual as well.
Exactly.
Could both of you share more on, I guess, if you were to build an ML org like from scratch, right, and scale up to 100 people, for example, what are some of the other key steps and maybe kind of like gotcha trip up moments to be conscientious of during that journey?
Yeah. Well, it's the same trick that I've used more or less sort of throughout my career in startups or in large teams as we were building up teams. And this is shamelessly borrowed from the Google method, right? Which is that, you hire the first 4 or 5 people that you bring into the team. You bring them so that they form a highly cohesive team that with together, the sum of their knowledge is greater than that of the individual parts. And they are actually more effective champions for the organization than anyone else, right? It is people, basically Google observed this pretty early on. It is like you hire the best and brightest, they will naturally attract the best and brightest. There's some level of gravity at play, which is kind of always the case. And not every organization is the same. Therefore, what is that core germ, the seed of that organization needs to be very carefully thought of and considered. And if you get that right, the rest of the organization and your value systems and culture and everything else essentially get propagated on down. Beyond that, I think it is a mix of, I think a general theme throughout this conversation has been, you need to have 4 groups of people be on the same page in order to pull off effective AI solutions. Number 1 are domain experts, people that know what this domain's about, what the data sets are, and so on. Number 2, you need product managers that think like a product manager, meaning that should you build this? Why should you build this? If you build it, will they come? Is there sufficient amount of revenue or lift that's associated with it? Number 3 are the algorithmics folks, or what we consider sort of like machine learning data scientist types. And number 4 are systems and performance engineering folks. When these 4 groups of people are on the same page about what to build, why to build, how to build, and how does it scale and actually operate at scale in production, then you have the elements of success. Almost all failures result from one or more of these groups not being on the same page. There's no questions asked, and which means that an effective AI ML organization, often you won't have the domain experts in this organization. So my quest for the most part has been, can I merge the systems engineering teams and the machine learning and data scientist teams together to be one really cohesive group, meaning that you take a data scientist or an ML specialist, and can you give them sufficient level of training so that they move closer toward the systems engineering capabilities? And vice versa. Take a systems engineering person and try to move them along the path of much more familiarity on the AI, machine learning, and algorithmic expertise. Right? And it takes time, but I think it is absolutely possible to do. So a perfect team is where you have people that can do both. Engineering teams, engineers can do data science, and data scientist teams can do engineering, right? And when that blend happens is when really good stuff starts to happen. The others, of course, are much more about sort of like, okay, understanding the context of the company, the business product.
Fantastic. And it seems like the cross-pollination and just very, very clear, like a larger organizational structure where ideas can be shared, expertise can be shared, and absorbed across different departments is really, really key.
Correct. Exactly. Yes.
One more question would be regarding the concept of mentorship. In both of your personal journeys, who do you look up who do you look up to for inspiration and mentorship, and how do you suggest some of the up and coming leaders within the SVLC might find potential mentors to help develop them in their career? Chu-Chung, would you like to go first?
Sure. I actually ask myself these questions, and I know this probably, I would say, a controversial opinion. And I do lucky to get 1 or 2 mentor in my career who actually put a lot of things on me and help me grow. And but I consider those things as outlier or lucky. And I think a lot of time people thought they want to find a mentor and they cannot find one. And I would say this applies to almost everyone, including myself. The reason is that if you think in that way, the one who need to mentor you or you look up to, they're always busier than you, right? So other than your manager, which he has or she has the responsibility to coach you, And if you want to find another mentor, then the question you should ask yourself is that how can I create this relationship is mutual rewarding, and why the other side of the person want to be my mentor. So eventually I changed my strategy, and I think that helped me a lot. The first thing is that some people are your mentor, but they may not meet with you regularly, right? So you can learn by someone's failure, which is cheaper because it's not your own failure, right? So they are your mentor, even you don't want to agree, but they probably say, how can I be your mentor? I just screw up, right? I say, no, when I see you screw up, I will always set up a coffee, chat about failure, chat about things people try. So I don't call it the mentor section. I just say, hey, that's. I also meet with other CDO. We from time to time we just chat about things and get an idea from others. And this section to me is very rewarding because sometimes we need someone who are less biased in our domain and give you a different opinion. So I consider all of them are my mentors by the people around me, not just the one who say, okay, you will meet with me every 2 weeks. I think that's number one, the trick number one. The number two is that I actually read a lot of good books. A lot of people share their career journey. No matter any group or anyone who are successful or any leaders, you can read a lot of books, and you can, to some extent, they are your mentor, because when you see their perspective, no matter about management philosophy or their personal journey, or even just talk about a technology, they are your mentor, right? So mentor can be one way that even you don't talk to the person, you read the book they wrote or bibliography, right? So anything can be your mentor. So that's how I define mentor. But if I really want to find a mentor, usually what I'm trying to find is a sponsor, is someone who will give me job, but not to tell me what to do. I mean, it's like when I say sponsor, is that you need someone to actually give you more responsibility, and that's when you are working in a big corporation. You want to build a relationship with not just your manager, but also people who are senior than you, and your goal is to find those sponsors who actually believe in your eager to success and your eagerness to grow yourself, and say, okay, fine, I have a presentation. I need someone to help me to polish the presentation, but the presentation due on Monday morning. So are you sure you want to do that on the weekend? Because I'm going to do myself, but if you want to do with me, then I can do that. And I think all these things, like this opportunity, some people call them as like a task or a job. But to me, is that if I can have opportunity to work with someone I respect or I aspire, no matter it's working hours, non-working hours, when I see this opportunity, I would just go like a shark, go to see something, I would just bite it and never let it go. I said, of course, call me anytime, I'm always at your service. And I think that by taking this opportunity, I built a few friendships, and they are not eventually want to call themselves my mentor, but in my career, they always give me advice, and I really appreciate it.
That's fantastic advice. I love the it's actually similar to the concepts of like business development and sales. Is the aggressive mindset to always be looking to add extra value as well to establish the relationship.
Exactly.
What would be your advice on mentorship as well?
Yeah, for me, I think mentorship is a very big deal. The point that Chu-Cheng made is also very true. So, I have a lot of mentors that I think don't think of themselves as my mentors because I'm reading from books or following them on podcasts or, and learning from their sort of, collective successes and failures. So from that perspective, there's a lot of them, whether it be Andrew Ng or Kai-Fu Lee and so on. More closer to home would be folks within your own enterprise that you actually respect, right? That you see, it's like, that's a person that I really want to be like, right? And for me, I was kind of lucky pretty early on with one of my managers. My manager was a chief technology officer at a company called Verity where I was at, and he's now the VP of engineering at Google. So he runs all of search, ads, the whole sort of like a big empire he has there. So clearly he's done well. This kind of individual that you seek out is someone that that you must recognize as someone that can add sort of specific personalized advice and context and coaching to your needs, right? Like you're saying, it is not at the tactical level, but more about career advice or things that you ought to pick up on, things that you need to improve upon, or, and it can be from a wide variety of things, right? In terms of how you're communicating, or how good or bad you are at self-awareness, or what is what's your strategic line of thinking, or understanding how to network better, and so on. So I have been lucky because I've recognized the value of sort of this networking pretty early on. I would suggest one tactical move is like you should plan on basically doing about 50 coffees a year. It doesn't have to be with 50 distinct people, but 50 coffees. Basically, it can be as small as a 10 or 15-minute sort of, coffee or conversation or whatever, but be cognizant of sort of the thing that you are talking to the individual about. It needs to be sort of focused with either a question that is asked a priori for which they may or may not have the answer, or if they don't have the answer, and if they're willing to sort of give you the assistance, it's easy for them to refer you to somebody else. Like Chu Cheng pointed out, the folks that are sought after as mentors are usually very busy, right? So it is, don't waste time to ask for specific advice and coaching, and always be networking. This is in it is effectively a lot of sort of like good comes out of good networking.
Instead of ABC always be closing, it's ABN.
They always be networking. Yes, yeah.
I love that as a good OKR, right? As for the 50 coffees.
50 coffees, yes.
So we are on. I think we have about 1 minute left on our event, and I really wanted to thank Pradeep and Chu Cheng again for taking time today to share your insights and share your time with us. It's been an absolute pleasure. I think the final, I guess, question I would love to leave both of you with would be if you have those book recommendations or other types of media recommendations for those that are aspiring to develop their leadership within and get more exposure to the AI ML space. What would be a few recommendations?
Yeah, I'll start first. I have three. There's a classic. It's called Learning from Data by Yasser Abu Mustafa, who's a professor from Caltech. It is an extraordinarily popular book and a series of lectures that are available online for free, and you should do it. It actually sort of like brings together a variety of theoretical foundations and of actual sort of applications of machine learning. Starts out by defining what it is, why it is even possible, and what can be done with it. It is, and gets into a fair level of depth. It is, if you can solve most of the exercises in the back of each chapter, you should call me immediately. Yes, they are super hard and very well done. That's my first. Second is a relatively new book, which is a collection of essays. Mm-hmm. It's called Possible Minds, 25 Ways of Looking at AI. Sort of charts the history of, machine learning and AI through the AI winter and sort of where we currently are at and ways of looking at it. And the last one is more of a management book that I would recommend. This is what's called The High Output Management by Andy Grove. It is fantastic in terms of, it has nothing to do with machine learning. It has everything to do with how you manage people and how you deal with them empathetically and how you communicate and impart knowledge to large groups of people for collective success. Yeah. Anyway, I wanted to thank you, Ross, and the entire group for inviting me. I sincerely appreciate the initiative and the immense work that you guys are doing for bringing communities like this together.
Thank you, and fantastic recommendations as well. Chu Cheng.
Sure. By the way, thank you for for inviting me today. I think you asked so many good questions. I also learned a lot from Pradeep. So again, I get a mentor without calling it a mentor. So you see, this is how you learn.
That works.
I actually want to recommend two books. Nowadays about AI, I usually learn my AI knowledge by reading paper directly and also go to conference. So all the conferences I go, basically the field I'm interested in. And but there are two books I think influence myself a lot. And I think before you do any AI or being managing people, try to manage yourself. I think managing yourself is not as easy as you thought. So I recommend two books about managing yourself. The first book is called Great at Work by Dr. Hansen. So Great at Work, basically, they do some research and identify successful people. There are 7 habits they always do. Like, for example, they will show you research will tell you 55 hours is the maximum you can work in a week. Don't go above 55. You are going to make a mistake. So even if you want to work hard, 55 is a research limit, right? So I think all this finding is very insightful to help me to guide myself. So the first book I recommend is Great at Work by Dr. Hansen. And the second book is that I learned when I become a manager and eventually become an executive. I find it's actually very useful, called Don't Sweat the Small Stuff, and It's All Small Stuff. Yeah. And it's written by Richard Carlson. I think that the book is very good because you are going to see a lot of things that you won't enjoy in your career. You will have a setback. You will have someone who don't collaborate with you or being unreasonable. You can run into COVID and you get stuck at home. And you can run a lot of adversary situation in your life. And I think you need a book to make sure you always feel optimistic and with energy. So by keeping positive thinking and by managing yourself well, I think it's a good start.
Awesome. Fantastic. Well, and thank you for both of you for the great recommendations. Afterwards, I'll be putting together a short wrap-up article in addition to posting our link online. We're streaming on YouTube. But I'll make sure to post everyone's recommendations and some of the insights as well from our conversations today. But Chu-Chung, Pradeep, thank you again for taking time to share. It's been an honor and a pleasure. For those who are looking forward to our upcoming events, the SVLC should be targeted for November 10th, but we'll be posting a notice once everything is settled down for the next topic on cybersecurity in a post-COVID world. Again, thank you again to Pradeep and Chu-Chung for taking time to share with us. And thank you again to Intellipro and Flag Dream for helping to co-sponsor our media for tonight's event. Highly appreciated.
Thank you.
See everyone on the next session.
Thank you so much.
Bye.
See you.